Okay, let's try and solve this numerically using Excel. So as usual, to solve it with numerical method, we have to set up a step. Now it's a height step, so we'll call it DH, and let's say 100 meters. We know that the atmosphere changes over a height of several kilometers, so 100 meters sounds reasonably small, though we can check that afterwards by seeing if it makes a difference. And now we're going to have a column of heights, a column of pressures, we're going to have a column of density, and a column of change of pressure, dP. Now we'll start at a height of 0, sea level, and a pressure of 101,000 pascals. Now the density is equal to the pressure divided by the constant C that we worked out, which is 84,000. So that's about 1.2 kilograms per cubic meter at sea level, so that's all good. Now what's the change in pressure? Now our equation was that the change in pressure is minus the density times G times the delta H. So it's equal to the density times G, 9.8, times the height step. We need to put dollars in there so that when we drag it down it still points to the same absolute cell. Okay, so the pressure drops off by 11,000 pascals over the height of 100 meters. Alright, so now we should be all set up, and we need to set up a new height over here. New height equals the old height plus the height step. And we'll need to put dollars there, so the height step always refers to the same absolute cell. The new pressure is going to be equal to the old pressure minus the pressure gradient. Oops. And everything's relative there, so we don't need to add any dollar signs. And the equation for the density just depends on the pressure, so that can remain the same, and dP can remain the same. And now we can drag that down. And there we've got it. So we can see, for example, that if you're at top of Mount Kosciuszko, about 2,300 meters, the pressure should be down to 77 kilopascals from the 101 at the sea level, so it's a reasonable difference in pressure. By the time you're at the top of, say, Mauna Kea Observatory, where I spent much time, you're down at 59 kilopascals, and by the time you're at the top of Mount Everest, just over 8,900 meters, you're only at 35 kilopascals, so the pressure is very much lower there. When you go higher still, the pressure keeps on dropping, as does the density, but it's still some pressure even at those heights. Now we can plot it. We can select this column. Scroll back, or a PC can hold down the control key and select that column. Be a different key on the Mac. Got our two columns selected, so insert, recommended chart will probably do us. This one looks good. And then we've got density as it drops off with altitude.